So when you're taking a watch apart, for the most part, they're little tiny screws, and you use a small tipped screwdriver to unfasten one of the screws, and then you grab the screw with a pair of tweezers. Maybe you unscrewed this screw that's on the wheel, and so then you have to get the wheel off, and you carefully disassemble everything, inspect everything, get it cleaned, put it back together, put the appropriate oils on the appropriate places, and see if it works. So that's kind of the general flow. But there are a few parts that are a little bit tricky to get off of this thing. They don't just unscrew and then trivially come off. One of those pieces is called the cannon pinion. The cannon pinion is involved, and I'm a bad cameraman. The cannon pinion is this little thing right here, and it connects to a shaft on the bottom that comes up off of one of the wheels on the bottom. So that shaft comes all the way through, and then this cannon pinion is friction fit on that shaft. So it's really tight, and it won't just slide off or anything. But that makes it difficult to remove. You could use some tweezers and just grip. There's a little groove down here, and if you grip them with the tiny little tweezers and crank it off, like it would pop off, probably. But you might pinch things that are you might crush the cannon pinion and cause it to deform. You might twist things, you might break things. It's ultimately it's bad, and you don't want to lever off the surface of the watch either. So ultimately, there's got to be a better way, right? So what professionals use is this $200 tool from a company called Burgeon, a Swiss company, and it has little teeth that it has an extending part. Um, like it's got a long shaft and a lever that you squeeze with your hand, and then it's got a vertical part, and that vertical part has kind of like a little ring that sits down on the surface of the watch, and it has three little teeth that kind of squeeze onto the part. And once they squeeze, your lever motion from above causes the ring to push down, and the gripper part in the middle, the chuck, I guess, to pull the thing off straight up. It's a fancy little tool. It works great. It's in one quick squeeze motion. You pull the thing right off the watch with no problems. The problem is that thing costs $200 to buy, and I didn't want one tool that cost $500 or $200 that just sits on the shelf, except when I'm pulling a cannon pinion. That seems a little outrageous to me, especially as a hobbyist. So I was trying to come up with a way to replicate that behavior, but without spending so much money. So what I've done is I bought a pen vise. This was long ago when I was kind of noodling on things. But a pen vise has a similar thing. Like there's this collar on the front, and then a collet underneath that has jaws. And those jaws have an angled tip, and this collar has a hole that's too small for the whole collet to fit through, but the tip will fit through. So, and it's threaded on the back. So when you screw it down, it causes the distance here to shrink, so the collet has to get kind of pushed through the hole, right? So like that. And then as you continue to extend it, the more of the angled collet gets pushed through the hole, causing the jaws to close a little tighter shut until ultimately it's all the way closed. Now this one has a tiny little pinhole. The thing came with two double-sided things, but this is the right size for the cannon pinion, believe it or not. So basically my idea was that I just get a pen vise, and is it this way? Yeah. Slip it down and pinch it tight. Now my tool has a hold of the cannon pinion now at this point, but I still got to pull it off. I got to pull it off straight, and I got to hold the watch down. And that seems like a problem, like to me, that I'm gonna twist it or have now I have a lever arm on this thing and I'm going to cause damage. So that's no good. So I got to come up with something just a little bit better than that. So what I've done was I 3D printed what? So what I've done was 3D print this pair of plastic tools, parts. This part screws onto this part with threads, which were a pain to figure out. But ultimately, this is a housing for the pen vise. So it slides through the hole snugly, and then the hexagonal rotating part at the top of the tool, kind of like this, so you can put pressure down and rotate it. But that part fits into this part at the top. So when it's screwed all the way down, the thing is extended. I put a gap here so I can pinch the vise, and then I can manipulate the tip using the friction from my fingers and such. Right. So now what I do is I slip the jaws of the pen vise down. And then, if my camera will, okay. Then I twist this part to get it to grip the cannon pinion properly. Then I hold it nice and straight and just rotate it down. So now this plastic part is going to extend down. It's going to press on the face of the watch, like so. Nice and careful. Now it's tight, like it's ready to come off. And so then I keep twisting, and off it comes. And so now I've got the cannon pinion is held in the teeth, in the jaws, just popped straight off with no problems at all. It's nice and easy. So I'm pretty excited about this. This is the first tool that I've built using my 3D printer. I plan on building a whole bunch more, just because it's fun. I get to think through how to solve a problem, and then I solve it using my brain.